Okay guys, so this is 6.4, the sum and difference formulas. So I have them written out for you right here. So it'd be a good idea to pause the video and copy them down. The first sign is cosine, and so if you have the sum of two angles in there, one angle is alpha and one is beta, then the cosine of alpha plus beta is cosine alpha, cosine beta, minus the sine of alpha, sine of beta. The cosine of alpha minus beta is going to be the cosine of alpha times the cosine of beta. Oh, and we didn't finish that one. Hold on one sec. Plus the sine of alpha, sine of beta. And cosine pi over 2 minus alpha is the sine of alpha. And that makes sense because if you think of the graphs, they're the same, just shifted over. Okay, then the sine formulas are similar. So sine of alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So the way I remember it is that for cosine, they're the same first. So you have the cosines and then the sines. But with the plus, it's a minus. With the minus, it's a plus. With sines, the plus is with the plus, but they're opposites. You have a sine and a cosine and a sine and a cosine and a sine. So that's one way to remember it. So why are these useful? These are useful if we need to find the value of a angle that's not on the unit circle, but it can be made up of two angles that might be on the unit circle. Okay, so first I want to find the exact value of cosine of 75 degrees. Well, 75 degrees is not on the unit circle. So my first step is to write 75 degrees as the sum or difference of two angles on the unit circle. Well, I know that 75 degrees is the same as 30 degrees plus 45 degrees. So now we have the sum of two angles that we know. So it's the cosine of 30 plus 45. So I'm going to go use this formula here. So it'll be the cosine of 30, cosine of 45, minus the sine of 30 degrees times the sine of 45 degrees. So I know that the cosine of 30 degrees on the unit circle, that's pi over 6, that would be a rad 3 over 2. And the cosine of 45 degrees is rad 2 over 2. Minus the sine of 30 degrees is a half. And the sine of 45 is rad 2 over 2. So I'm going to multiply those. They're both under the radical, so I multiply them under the radical. So that'll give me a rad 6. 2 times 2 is over 4, minus 1 times rad 2 is just a rad 2. 2 times 2 is 4. So then all together, and I can't do rad 6 minus rad 2, okay, and all over 4. And that will be my final answer. And you can just leave it in that form. Don't try to simplify it anymore. Okay, let's try another one. So B, we're going to try to find the cosine of pi over 12. Okay, well that's a small angle. And since it's small, it might be easier to find it as the difference of something. Well, I know that pi over 12, that could be a 4 pi over 12 minus 3 pi over 12. Well, 4 pi over 12 is the same as pi over 3. And 3 pi over 12 is the same as pi over 4. So we're going to write this as the cosine of pi over 3 minus pi over 4, okay, because that's going to give us a pi over 12. So now I'm using cosine and subtraction, so that'll give me, it's going to be the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 and the sine of pi over 4. Because it's cosine, so they match, but I'm using, instead of minus, I use a plus. So that's my cosine subtraction formula, my difference of cosine. Okay, so cosine pi over 3 is a half. Cosine pi over 4 is rad 2 over 2. Plus sine of pi over 3 is going to be rad 3 over 2. And the sine of pi over 4 is rad 2 over 2. So that's going to give me, let's see, rad 2 over 4 plus rad 6 over 4. It's a very similar answer. It'll be rad 2 plus rad 6 all over 4. That'll be my final answer. Okay. So let's do a couple more examples like that. Okay, let's try something with the sine. So we're going to do sine of 7 pi over 12. Okay, well, how can you get a 7 pi over 12? Well, that could be the sine of a 4 pi over 12 plus 3 pi over 12. That'll give me a 7 pi over 12. Well, 4 pi over 12 is really pi over 3. And 3 pi over 12 is really pi over 4. So it's going to be the sine of pi over 3 plus the pi over 4. And if we look back at our formulas for sine, so we're going to use this one. So it'll be sine alpha cosine beta plus cosine alpha sine beta. Okay, so it'll be the sine of my first one, so sine of pi over 3, times the cosine of the second one, pi over 4, plus the sine of the second value, pi over 4, times the cosine of the first value, pi over 3. Okay, so make sure these don't match, guys. And so the sine of pi over 3 is going to be rad 3 over 2. Cosine of pi over 4 is rad 2 over 2. Plus the sine of pi over 4 is rad 2 over 2. And the cosine of pi over 3 is 1 over 2. Which will give us a rad 6 over 4 plus rad 2 over 4. Another same answer. Which makes sense because they're angles and they're just going to be in different quadrants. The 7 pi over 12 and the pi over 12. So it makes sense that they're very similar. Slash the same. So rad 6 plus rad 2 all over 4. Okay. And now we're going to do a similar one. Okay, but a little bit different. So this one, I still want you to find the exact value, but it's going to write it in a different form. We're going to do the sine of 80 degrees times the cosine of 20 degrees minus cosine of 80 degrees and sine of 20 degrees. So you can see now that these match, right? So you can see that this 80 and 80, 20 and 20, they match. There's a minus in the middle. So I want to see what formula that looks like. So let's scroll up. It's sine, cosine, cosine, sine, and there's a minus. Okay, so let's see. Sine, cosine, cosine, sine, and there's a minus. It looks like it's in this formula, which is sine of alpha minus beta, with the first one being that 80. So you could rewrite this using the formula backwards to be the sine of 80 degrees minus 20 degrees. Well, 80 minus 20, that's just the sine of 60 degrees, which you know the sine of 60 degrees, okay, 60 degrees is pi over 3, is going to be a rad 3 over 2. So your final answer will be a rad 3 over 2. It's that easy. Okay. So now let's do something a little bit more complex using this. So let's do example number 2. Okay, so here's example number 2. This is our given in blue. It's giving you that there's a sine of alpha is 4/5, and it's giving you that the angle is between pi over 2 and pi. So that means the alpha angle is between pi over 2 and pi, which falls here, which is quadrant 2. So that's what that information is giving us. So remember, that helps with the positives and negatives. And then it gives you that the sine of beta, take note that these are different angles. One is alpha, one is beta, okay, is negative 2 over rad 5, and it's between pi right here and 3 pi over 2. So that's telling you it lands in quadrant 3. Okay, those are the givens. Now this is what it wants you to find. The cosine of alpha, the cosine of beta, the cosine of alpha plus beta, and the sine of alpha plus beta. So let's find the cosine of alpha first. Okay, so for A. So I know that the sine of alpha is 4/5, which is your y over your r. So your y is 4, your r is 5. Okay, so you can use x squared plus y squared equals r squared. Okay, and you'll get 4 squared plus y squared, or sorry, x squared plus your 4 squared will give you 5 squared. Or you should know that at that point it's a 3, 4, 5 triangle and you get that x is 3. So then I'll know that my cosine of alpha is going to be 3 over my R5. And I'm in quadrant 2. In quadrant 2, cosine is negative, so it's a negative 3/5. It doesn't ask me to find the other ones, just for A, so I can stop there. So B, I want to find the cosine of beta. Okay, so I know the sine of the different angle beta is negative 2 over rad 5. This one's not a perfect triangle, so I know that my y is negative 2 and my r is rad 5. So I am going to use the x squared plus y squared equals r squared. I don't know my x, but I know this will be negative 2 squared and this will be rad 5 squared. So I know that this will be, let's see, x squared plus 2 will equal 5. So I'll subtract 2, so x squared will have to equal 3, which means that x is rad 3. Okay. So I know that x is rad 3, so then my cosine of beta will be a rad 3 over rad 5. Okay. And let's see. Oh, hold on. Something went wrong there. Negative 2 squared. I'm sorry, guys. What's negative 2 squared? It's 4. Okay. So that would not be correct. You made an error. It didn't seem right. So negative 2 squared will equal rad 5 squared. Going back. So x squared plus 4 will equal 5. So x squared will equal 1. So x will equal 1. So it'll be rad 1, which is 1. So your cosine will be 1 over rad 5. Okay, and I know that it's in quadrant 3, beta, so that means it's a negative 1 over rad 5. So now you guys can see that you should have your sine of alpha, your cosine of alpha, your sine of beta, and your cosine of beta. So now when I go for C and D, I have everything that I need. Okay. So for C, it wanted cosine of alpha plus beta, which I know by my formula is cosine alpha, cosine beta, minus sine alpha, sine beta. So cosine alpha was negative 3 over 5. Cosine beta is negative 1 over rad 5. Minus sine of alpha was 4 over 5. And sine of, that should be beta. Sine of beta was negative 2 over rad 5. Which will give us a 3 over 5 rad 5. Minus negative 8 over 5 rad 5, which ends up being 3 minus negative 8, 3 plus 8, 11 over 5 rad 5. Remember, I don't make you rationalize it, so you can leave it like that. So now we want to do D, was asking us for the sine of alpha plus beta, which you know is going to be the sine of alpha, cosine beta, plus sine of beta, cosine alpha. So the sine of alpha, going back, was negative 4 over 5. The cosine of beta was negative 1 over rad 5. Plus the sine of beta, which was negative 2 over rad 5. And the cosine of alpha, which is negative 3 over 5. Did I get any of those wrong? I think I put them in right, so we're good. So that means if I multiply, I get negative 4 over 5 rad 5 plus negative 2 positive 6 over 5 rad 5, which gives you a 2 over 5 rad 5. Okay, and nothing cancels out, so you are done. Okay, so that was a long example, but not too bad. Okay, we just have a little bit more. Okay. So I'm going to scroll down. Pause the video if you need to catch up. Okay. So now I'm going to give you guys the formulas for tangent. Okay, they're very similar. So the tan of alpha plus beta is the tan of alpha plus the tan of beta over 1 minus tan alpha tan beta, and the tan of alpha minus beta is the tan of alpha minus the tan of beta over 1 plus tan alpha tan beta. Okay. So doing an example with that, so we'll do example number 3. So we're going to try to find the tan of 75 degrees Well, we know the tan of 75 degrees. Well, 75 can be the tan of 30 degrees plus 45 degrees. And it doesn't matter what order. You could do 45 plus 30 and it'll work out to be the same. So then you'll have the tan of 30 degrees, since that's my alpha, plus the tan of 45 degrees, which is my beta, over 1 minus tan of 30, tan of 45. So, and I need to figure out what that tan of 30, tan of 45 is. Okay, so to do that, I need to do, okay, well, I know tan of 30 is sine of 30, and the sine of 30 degrees is 1/2 over rad 3 over 2, which is going to end up being a 2 over rad 3. That looks incorrect. Let's see, 1/2, 1 over rad 3, my bad. And you can leave it like that. Or it might be easier in this case to switch it to rad 3 over 3. I'm going to multiply it by rad 3 on the top, just because it's going to make it easier later. And the tan of 45 degrees, that's easier. It's rad 2 over 2 over rad 2 over 2. So it's going to be a 1. So the tan of 30, which is rad 3 over 3, plus 1 over 1 minus rad 3 over 3 times 1. Well, I'm going to change that 1 to make it easier as 3 over 3, because that's the same as 1. So I get rad 3 plus 3 over 3 over, let's see, and I'll change this to a 3 over 3. 3 minus rad 3 over 3. And if you multiply by the reciprocal, the 3's cancel out, and you get rad 3 plus 3 over rad 3 minus 3, or 3 minus rad 3. So it's rad 3 plus 3 over 3 minus rad 3. Okay, just like that. Okay, so pause the video if you need to catch up on example number 3, or if you need to check out multiplying by the reciprocal at the end there, how that worked out. And we're going to move on to example number 4. I know you guys love proving. This is the last example. So you just need to prove the identity that cosine of alpha minus beta over sine alpha sine beta is equal to the cotangent of alpha times the cotangent of beta plus 1. So what we're going to do here is, remember, we're going to work with the left side. Okay, so working with this side to try to get it equal to the right side. And now you can use all of those sum and difference formulas that I gave you guys. Missing some letters there. So cosine alpha minus beta, remember, is going to turn into cosine alpha cosine beta plus sine alpha sine beta over sine alpha sine beta. Now I'm going to use something that's like going back to elementary school. Okay, you can write it over each of these parts over like their own denominator. Okay, so it'll be cosine alpha cosine beta over sine alpha sine beta plus the second part, sine alpha sine beta over sine alpha sine beta. Well, I can also already see that these will cancel out and become a 1. Okay, so now I have to work with this part. I see that I can break it up here. So it'll be cosine alpha over sine alpha times cosine beta over sine beta. Because it's just multiplying, so you just multiply across. Okay, so this would just multiply to become cosine alpha cosine beta on the top, sine alpha sine beta on the bottom. So I just broke it up by multiplying, since you can just multiply across with fractions. Well, cosine alpha sine over sine turns into cotangent, so that's cotangent alpha. And cosine beta over sine beta is the cotangent of beta. And I already got my plus 1, which that now looks like my right side. So I know that equals my right side, cotangent alpha, cotangent beta, plus 1. So I am done. That is my proof, and that is your last example. I know you guys love proofs. See you in class tomorrow.